Hello everyone, welcome back to a new interesting case study. My name is Vijesh and today we are going to see a new case study based on multiple same column predicates. So let's explore this. So this is a new SQL query. Select e dot first name, e dot last name, e dot hire date from employees E, comma departments T. So this is a join operation between your employees table and the departments table where e dot employee ID in 100 to 105 and e dot employee ID is greater than 0. So you see there is a same column which has been introduced twice in the where part of the clause, right? And then there is a join operation. E dot department ID is equal to d dot department ID. So in order to tune this query, let's go back to our fundamental approach, which states that you have to start with such a column in the where part of the clause, which is going to give me very less number of rows. But in this case, as we see, employee ID has been occurring twice in the where part of clause and that too with different conditions, right? So in such cases, what we have to do, it's very simple. Like I said, let's apply the fundamental approach itself. Whichever condition is going to give the less number of rows, that is the column which Oracle should first access. So that very less number of rows are fetched first and then filter it out, right? So if you see in the employees table, employee ID is the primary key. So e.employee ID in 100 to 105 is always going to give you only 6 rows because employee ID is the primary key in your employees table. But e.employee ID greater than 0 is going to qualify for your entire table because definitely all your employee IDs are greater than 0. So in order to tune this query, we have to start with e.employee ID in 100 to 105 and then filter it out to see whether the employee IDs are greater than 0 or not. We obviously know that all the employee IDs between 100 to 105 is greater than 0. So this condition, employee ID greater than 0, automatically will be a part of the filter clause, but none of them will be filtered out. So and then whatever employee IDs has been scanned between 100 to 105 will go for this join operation, and this join operation is again going to give me back 6 rows because in the departments table department ID is a primary key, right? So just to brush up our concepts once again, we should not be starting with the join operation first, right? Because if you start with the join operation, I have to scan all the department IDs from the departments table. I have to scan all the department IDs from the employees table and then do a join operation. So this is a very lengthy approach, right? So that is the reason why we have to go with the fundamental approach, that is nothing but accessing a column in the where part of the clause, which is going to give me very less number of rows. So the conclusion is I have to start with e.employee ID in this 100 to 105 and then go for the join operation so that I am going to give my exact 6 rows as part of the select output, right? So let's see whether Oracle has actually did it or not. So this is the plan which Oracle has taken, right? And if you create a parent-child relationship for this, then the third operation is the innermost and this is the first operation which is going to get executed. Later on, second will execute. Now let's see what the third operation is. It does index full scan on employee ID using an employee ID index. And the third operation, if you see, it is accessing the employees table using e.employee ID greater than 0, right? That means it is scanning for all the employee IDs in the employees table, which obviously we don't want. So that is the reason why you're seeing an expected rows to be 107, right? And then the second operation will execute, which is table access by index row ID. That means it is filtering out from all the employee IDs which have scanned from 100 to 105, right? So this is something which we wanted to avoid. And then it is doing a join operation with the departments table. That is the fourth operation here. So obviously Oracle is doing the exact opposite. We want Oracle to start with e.employee ID in this, right? And then it should go with the filtering on the employee ID greater than 0, right? So in order to fix this, what we can do, we'll just again pass a simple hint that is leading E, right? That will tell Oracle to start with the employees table, right? But again, if you see, both the columns are having the employees itself. So how the leading E is going to help is by using a nested loop hint. So when you use a nested loop hint, the Oracle's expectation is to work on a row source which will be smaller, right? So in this case, if I start with e.employee ID in this row source, I'm going to get 6 rows. And if I start with e.employee ID greater than 0, I'm going to get more row sources, right? So when you put a use underscore NL hint as well, along with the leading E, the expectation of Oracle is to start with such a leading E in this case employee ID, which is going to give a less number of row sources. Okay, so that is that is how we are going to fix. So before going that, let's see the table statistics. So I have shown this statistics in multiple of my SQL training case studies. So employees is having 107 rows, and the employee ID column is having 107 distinct values, right? So each employee ID value is unique. Similar in the departments table, department ID is the primary key. I have mentioned this resolution whichever I stated and written it here, and I have shared this case study in the link. You can find that in the description of this video. If you still want to confirm whichever condition of my employee is giving me less number of rows, you can always fire this query to check that. Select count of star from employees, where employee ID in 100 to 105 is going to give me 6 rows, which is a smaller row source. And if I go with the second condition, select count of star from employees, where employee ID is greater than 0, it is going to give me 107, which is a bigger row source. So obviously I have to start with employee ID in 100 to 105, right? So let's see after putting the hint how the query looks like. So I just put the leading E hint, and I have made the nested loop join between the departments and the employees table hint as well. Okay, so this is how the execution plan will look like after that. So let's analyze this execution plan again. So since if you make a parent-child relationship, fourth is the first operation. If you see the fourth operation, it is doing an access on the employees 100 to 105 rather than accessing employee ID greater than 0. This is what we actually wanted, and Oracle has actually performed the same, and you're seeing that the expected row is only 6 as compared to 107, which we saw in the previous execution plan. The next operation after that is going to be 5, which will be a join operation between the employees and the departments table. And this is how we are going to fix this query. So I hope you guys liked this case study, and if there are any doubts or suggestions, please feel free to drop a comment, and please subscribe to my video. Thank you so much.